Hey guys, welcome to Speed Day 1. During this unit, we're going to go back to the idea of rates, which if you'll remember from our ratios unit, are special types of ratios. Rates compare two quantities with different units. Speed is a special kind of rate that compares distance to time. Some other examples of rates might be glasses of water per day, or maybe when we were talking about deserts, rainfall per year. Rates are usually given as some amount of measurement unit per one of the other measurement unit. So when I say per one of the other measurement unit, that means that the one is going to be on the bottom. So for example, if I need to drink, let's say 8 glasses of water per day, remember that fraction bar can mean per or divide. Or let's say when we were talking about deserts, a particular desert receives 4 inches of rainfall per year. That unit on the bottom of our rate is one thing. So this is 8 glasses of water per 1 day and 4 inches of rainfall per 1 year. So like I said before, speed is a special kind of rate that compares distance to time. So let's take a look at this chart really quick here. And let's just brainstorm some units we might fill in this chart. If we're talking about, and we're going to actually start over here on the right, which is a little weird, but that's okay. If we're talking about time, we could talk about time in terms of minutes, or maybe hours, or even seconds. If we're talking about distance, we could talk about distance in terms of, well, maybe miles, kilometers, or even feet or inches or centimeters. If we're talking about speed, we could talk about speed in terms of miles per hour, which also looks like this, or maybe kilometers per hour, which looks like that. Okay. Now, what do you notice about these labels for speed? If you look at it carefully, you'll notice that it's a combination of distance and time. It gives a unit of some distance traveled over a measurement of time. All right, let's talk about some little animals here just a second. How far can this horse travel in 1 hour? Well, here's my speed right here, right? It says that he can travel 58 kilometers per hour. So that means that in 1 hour, he could have traveled 58 kilometers. How about in 2 hours? Well, if we're going to figure that out, we need to multiply it by 2, don't we? And if we do that, ooh, check this out. This is nifty right here, you guys. A little cross-canceling with our units helps us out in this unit. Okay, in 2 hours, he's going to travel 58 kilometers times 2, right? Which is going to be 116 kilometers. Assuming, of course, the horse can run that fast for that long. How about a cheetah? How far can a cheetah travel in 1 hour? Obviously 88 kilometers, right? How far can a cheetah travel in a half an hour? Well, if he's only traveling for a half an hour, he's only going to go half of the distance that he would travel in 1 hour. So he will have traveled 44 kilometers. Okay, so let's take a look at your notes, and we're going to look at the speedometers that you have in front of you and write down what the speeds that are shown. So go ahead and take a second and do that, and then come back and check your work. All right, so if we're looking at that first speedometer, it looks to me like that's 50 kilometers per hour, right? Because the little dial is pointing right at the 50. And on the second speedometer, we have a dial pointing to 65 kilometers per hour. And on the third, we have a dial pointing to 35 kilometers per hour. Which one of those speedometers indicates the fastest speed? Well, it's this one, right? That's kind of obvious, but we still have to talk about it. Okay, now we're going to draw and label what I call the speed triangle. The speed triangle is a visual aid to help us remember the 3 different formulas that we are going to have to memorize in this unit. And rather than just memorize them, just from scratch, if we can remember this triangle and just remember that distance is on top and that we write speed and time in alphabetical order at the bottom, it's going to help us a lot. Okay, so go ahead and copy that down really quickly. We have distance at the top, speed on the left, and time on the right, and then we have a division sign, and multiplication sign. And that's going to help us remember our formulas, because when we write the distance formula, distance is going to equal speed times time, which I lost my triangle there, but if you look up in your notes, which you just copied down, if we just go speed times time, that's going to equal distance. Time is going to equal distance over speed, or distance divided by speed, which we can conveniently see that from our triangle, because distance is at the top. We have a division sign right there. And then speed is distance divided by time. So make sure you have those written down. We're going to do some problems. Okay, our first one says that a van is traveling at a speed of 50 miles per hour. How far can it travel in 2 hours? Okay, because we have so many variables when we're working with rates, we are going to label these different things in our word problem. So I want you to label distance, speed, and time. Okay, in this problem, we're given a speed, 50 miles per hour, so we'll put an S up there. We're given a time of 2 hours, so we're going to put a T right there. Well, we're trying to find distance, right? So we're going to put a question mark right there with distance. Okay, so the first thing we're going to do is we're going to write the equation, then we're going to fill in the variables, and then we're going to solve. Okay, so let's do that. So we're trying to find distance, right? So that's going to go on the left there. And we need to use the correct formula. So distance equals speed times time. Now let's fill in our variables. Distance equals 50 miles per hour times 2 hours, right? So we're trying to figure out how far a van will go traveling 50 miles per hour in 2 hours. So this is nifty, you guys. If you check that out, we can cross-cancel units just like numbers, and that kind of helps us to remember what unit to put our answer in, because now all I'm left with is miles, right? So distance equals 50 miles times 2, which equals 100 miles. All right, let's try another one. So Eric is swimming at a speed of 40 meters per minute. How far can he travel? Oops, I've got a little mistake there. Let's write he there. How far can he travel in 5 minutes? Now let's start by labeling our problem. We've got speed here, 40 meters per minute. We've got a time here, 5 minutes. How far? Well, we don't know, but that's our distance. That's what we're trying to find. Can he travel in 5 minutes? So again, we need to write our formula, then substitute in, and then solve. So we're going to use the distance formula, since that's what we're trying to figure out. Okay, so there it is. And then our distance equals 40 meters per minute times 5 minutes. Cross out the minutes. That helps us to remember that we're going to end up with an answer in terms of meters. Our distance is 40 times 5, which equals 200 meters. Okay. I would like for you to turn with me to the next one. Okay, I'm just going to demonstrate number 6 and number 8, and then I'm going to ask for you guys to work the rest on your own. Okay, so in number 6, it says that a bullet travels 420 meters in 2 seconds. Find its speed in meters per second. So our first step is to label the problem. There's our time. 420 meters is our distance, and our speed is what we're trying to find this time. So we're going to label that with a question mark. And we're going to write our equation. So we're going to use the equation for speed. So speed is going to equal distance over time. Now let's substitute in our variables. Speed equals 420 meters over 2 seconds. And actually we could just write that with an S. That's just fine to do. Okay, and then so check it out, you guys. I'm writing the units. I'm keeping the units always in rates with the numbers that they belong to, and the reason for that is when I'm finished with my problem, it's going to give me the unit that I need to put my rate into. So obviously meters and seconds aren't going to cancel out, are they? So when I'm done, I'm going to have an answer in terms of meters per second. So my speed, if I divide 420 by 2, I'm going to get 210. And then my unit is meters per second. All right, go ahead and try number 7 on your own, and then do number 8 with me on the next slide. All right, so Shayla travels at a distance of 250 kilometers at a speed of 40 kilometers per hour. How long will it take her? Okay, so how long means that we don't know the time, right? That's what we're trying to find out here. So our distance is 250 kilometers and our speed is 40 kilometers per hour. So if we're trying to find time, we're going to use the time formula. Time equals distance over speed. We write the formula first and then we fill in the variables. Time equals 250 kilometers over 40 kilometers per hour. Okay, so kilometers cancel out. And our time, let's divide 250 by 40. You know what, let's cross cancel those zeros really quick. And let's divide 25 by 4. 4 goes into 25. 6 times, we are going to need a decimal there. And 6 times 4 is 24. 25 minus 24 is 1. Let's bring down that 0. 4 goes into 10 twice. 2 times 4 is 8. Let's bring down another 0. 10 minus 8 is going to be 2. 4 goes into 25 times, and then don't forget to put that decimal up in your quotient. So our time is going to equal 6.25, and our units is hours. And we're just going to leave it like that. We're not going to change it into hours and minutes. We're going to leave it in terms of a decimal amount of hours. Okay, I want you guys to go ahead and finish the notes on your own as Toyos, and your homework for this evening is workbook exercise 27.